Bismillahirrahmanirrahim, and Assalamualaikum warahmatullahi taala wabarakatuh, and to our lecturer Encik Abdul Halim. So this is our presentation of the thermodynamic assignment. So my name is Muhammad Afiq Syari bin Rosli, and my matrix number is B0922100017. So this is our content of the presentation. So I will present about the introduction, history, and application. So our introduction and history about diesel cycle. So diesel engine frequently employ the diesel cycle, a thermodynamic cycle. It is named after German inventor Rudolf Cycle, who created it in the late 19th century. The diesel cycle is frequently employed in machines like heavy-duty truck, locomotive, ship, and industrial machinery when great power output and fuel efficiency are necessary. Diesel cycle explains how a conventional compression ignition piston engine operates. The fuel is injected, and as a result of the high temperature created by the adiabatic compression, it spontaneously ignites. Consequently, spark plugs are not required. Typical diesel car engine runs at between 30% and 35%. One of the most prevalent thermodynamic cycle found in car engine, the diesel cycle depicts how a basic compression ignition piston engine operates. The operation of a diesel engine is comparable to that of a petrol engine. The most significant distinction is that there is no fuel in the cylinder at the beginning of the combustion stroke. Therefore, automation does not occur in diesel engine. The diesel engine uses combustion ignition instead of spark ignition. Because of the high temperature developed during the adiabatic combustion, the fuel spontaneously ignites as it is injected. Therefore, no spark plugs are needed. Before the beginning of the power stroke, the injector starts to inject the fuel directly into the combustion chamber. Therefore, the first part of the power stroke occurs approximately at the constant pressure. Higher compression ratios can be achieved in diesel engine than in auto engine. So the next is application of the process. Diesel cycle is an internal combustion engine process of reciprocating engine in heat produced by the combustion of air in the combustion chamber, into which fuel is then delivered, ignites the fuel. Contrast this with the Otto cycle four-stroke petrol engine, which will start the fuel-air mixture with a spark plug. In addition to surface ship and diesel engine are utilized in vehicle, aviation, power plant, and other applications. In an ideal diesel cycle, the cycle system undergoes a series of four processes: two interceptopic and reversible adiabatic process, alternate with one isochoric process and one isobaric process. In isentropic process, compression stroke, the air is compressed adiabatically from state 1 to state 2 as the piston moves from the bottom dead center to the top dead center. The surrounding do work on the gas, increasing its internal energy, which is temperature, and compressing it. On the other hand, the entropy remains unchanged. A change in volume and their ratio is V1 divided by V2 are known as the compression ratio. Isobaric expansion ignition phase. In this phase, between the state 2 and state 3, there is a constant pressure idealized model, heat transfer of the air from an external source, combustion of injected fuel, while the piston is moving toward the V3 during the constant pressure process. Energy enter in the system as heat Q is at, and a part of the work is done by moving piston. Isentropic expansion, which is power stroke, the gas expand immediately from the state 3 to state 4, and the piston move from V3 to the bottom dead center. The gas work on the surrounding piston and lost an amount of internal energy equal to the work that leaves the system. Again, the entropy remains unchanged. The volume ratio V4 stroke V3 is known as the isentropic expansion ratio. Isochronic descompression exhaust stroke. In this phase, the cycle completes by a constant volume process, which heat is rejected from the air while the piston is at the bottom dead center. The working gas pressure drops instantaneously from point 4 to point 1. The exhaust valve open at point 4. The exhaust stroke is directly decompression as the piston move from the bottom dead center, which is point 1, to the top dead center, which is point 0. With the exhaust valve open, the gaseous mixture is vented to the atmosphere and the process starts anew. During the diesel cycle, work is done by the gas. The work is done on the gas by the piston between state 1 and state 2, which is isentropic compression. Work is done by the gas on the piston between stage 2 and stage 3 is isobaric heat addition, and between stage 2 and stage 3 which is isentropic expansion. The difference between the work done by the gas and the work done on the gas is the network produced by the cycle, and it is correspond to the area enclosed by the cycle curve. The work produced by the time the rate of the cycle per second is equal to the power produced by the diesel engine. So that's all for me. So next I will pass to my member.
I am Alif and I am going to talk about the working principle of diesel engine. Diesel engines are designed to ignite fuels without any igniting apparatus such as spark plug, which is well known on the gasoline engine. It uses highly compressed hot air to ignite the fuel rather than using a spark plug. The mixture of air and fuel is done in the combustion chamber and not in the inlet manifold. The working principle of the diesel engine are so interesting that only air is initially introduced into the combustion chamber. The air is then compressed at a ratio between 15 to 1 to and 20 to 1, 23 to 1, depending on the type of diesel engine and its application. The high compression causes the temperature of the air to rise, and at this point, fuel is injected on the hot air when the compression stroke is about to reach the top. All this takes place in the combustion chamber on top of the piston. The fuel injector helps in injecting fuels into the combustion chamber in small droplets and distributed evenly. The compressed air created creates its extreme heat, causing the fuel to vaporize from the surface of the droplets. The vapor is then ignited using the same heat in the combustion chamber. The vaporization of the droplets continued until they are completely burned. The combustion occurs at a substantially constant pressure during the initial part of the power stroke. When the combustion is complete, the combustion gases expand as the piston descends further. The high pressure in the cylinder drives the piston downward, supplying power to the crankshaft. The adjustment of the engine's speed is solely by the mixture quality. That is, the amount of torque produced is set solely by the mass of injected fuels. Always mix with as much air as possible. This results in the crankshaft rotational speed differences. Next, I am going to talk about the cycle diagram. There are four cycle of diagrams, and the first one is intake stroke. The intake valve will open and the exhaust valve will shut. The piston then will travel from CCD to BCD, and the air will drawn in. Next is the compression stroke. The intake and exhaust valve will shut. The piston will travel from BCD to DCD, and the temperature and pressure of air will increase. Next is power stroke. The intake and exhaust valves will also shut. Fuel injected into the cylinder and ignites, and the piston will be forced from TCD to BCD. And lastly is the exhaust stroke. The intake valve shut and the exhaust valve will open. The piston will move from BCD to TCD, and the combustion gases will be expelled.
Okay, I am Xiao Shubin. Now I would like to present about the advantage of the diesel cycle. The first one, fuel efficiency. One of the primary advantage of the diesel cycle is its superior fuel efficiency. Diesel engine typically achieve higher thermal efficiency compared to gasoline engine, converting a larger portion of the fuel energy into useful work. This efficiency leads to lower fuel consumption and reduced operating costs. Okay, the second one is the high torque and power. Diesel engines are well known for their ability to generate high torque, particularly at low engine speed. These characteristics make them ideal for applications that require heavy pulling power, such as in truck, construction equipment, and marine vessels. Additionally, diesel engines offer excellent low-end power, enabling efficient operating under heavy loads. The third one is durability and longevity. Diesel engines are designed to withstand the high compression ratio and the combustion process of diesel fuel. As a result, they tend to be more robust and durable than gasoline engines, making them suitable for demanding environments. Diesel engines often have a longer lifespan and require less frequent repair and replacement, leading to reduced maintenance costs. Okay. The next part I will present about the disadvantage of the diesel cycle. Okay, the first one of the disadvantage is the emissions. One of the primary concerns associated with the diesel cycle is the emission it produces. Diesel engine emit higher level of nitrogen oxide and particulate matter compared to gasoline engine. These pollutants contribute to air pollution and have adverse effect on human health and the environment. However, advancements in emission control technology have significantly reduced diesel emission in modern engines. The second one is noise and vibration. Diesel engines tend to be louder and generate more vibration compared to gasoline engine. This characteristic is due to the higher compression ratio and the combustion process of diesel fuel. Although efforts have been made to mitigate noise and vibration, diesel engines are generally perceived as noisier, particularly at night or under heavy load conditions. Okay, the third one is higher initial cost. Diesel engine and the associated equipment can be more expensive to manufacture and cost compared to gasoline engine. The higher cost is primarily attributed to the need for stronger material, higher compression ratio, and specialty components. This initial investment may pose a financial challenge, particularly for small-scale application or budget conscious consumer. Okay, thank you.
Okay, now I'm gonna explain about the suggestion to the further improve or modify the cycle. First, we can enhance air management and turbocharging. Improvement in turbocharging technology can exchange the air management system in diesel engines. Advanced turbocharged with variable geometry and twin scroll design can optimize the intake and air pressure, temperature, resulting in improved combustion efficiency and reduced emission. Additionally, we can use advanced waste heat recovery system can harness the energy from exhaust gases to further increase an overall system efficiency. Second, we can add advancement in fuel injection system. Investing in development and advanced fuel injection system can efficiently improve the efficiency and emissions performance of diesel engine. Further, refinement in fuel optimization, preference control of injection timing and duration, and multiple injection strategies can lead to even better combustions efficiency and reduce emissions. So next, development of advanced combustion modes. Exploring an advanced combustion modes such as charged combustion HCCI or practically premixed combustion can improve diesel engine efficiency and reduce emissions. The combustion modes offer the potential for simulation, reduction of nitrogen oxide and particulate matter, efficient while maintaining high thermal efficiency. Further research is needed to overcome challenges like controlling combustions and achieving stable operation. Finally, we can also utilization of alternative fuels. Investigating and promoting the fuel such as biodiesel, synthetic fuels and renewable diesel can contribute to the environmental sustainability of diesel engines. These fuels can potential to reduce greenhouse emissions and particulate matter while also ensuring compatibility and existing diesel engine. Technology and additional exploring the feasibility of hydrogen such as diesel engine either through combustion or fuel cells technology could offer long-term environmental benefits. Thank you.